Nope, no price. Hello everyone and welcome back to Arctic Retro, the retro channel from above the Arctic Circle. Okay, so today I have something very special to show you. Yeah, indeed it is retro and it is computer related, but yeah, still very special, and I'm not sure if I did the right thing here to take on this project, but I'll give it a go and I'll take you with me. So let's take a look at what I got here. So what the heck is this? Some large printed circuit boards or PCBs, as you obviously can see, and it contains a lot of old components, the chips, and everything is through hole, and yeah, these are actually boards for a coin game. And back in the day in Norway, these games were very popular. They were placed around in shops and everywhere, and yeah, I'll show you a little game here that actually simulates this game, and I remembered it myself. We used to hang at the shop back home in the 70s and 80s and play this coin game, and obviously we sometimes lost our weekly salary from our parents, and sometimes we won a few coins, but for the most part we lost, as always is with these kinds of machines. They were for the most part placed out by some kind of organizations like Red Cross or some other charity organizations. Yeah, it was like today you can't simply place gambling machines everywhere. It's a regulated market here in Norway, so only a few are allowed to place out gambling machines, and we have no casinos in Norway. It's not allowed, which is a good thing, I mean. Anyway, let's take a look at this game, and yeah, as you can see, it's a large machine and it contains a lot of coins, and when you hit this little trigger with your finger, you shoot out one coin. Back in the day when I was using this, the coin was 1 krone, which is 1 NOK, which is around 0.10 of a euros today, so yeah, or 10 euro cents, and you could win from 2 up to 10 kroners at that time. I think later there came machines where you could win more, but yeah, so it wasn't a lot you could win. Let me just take a break here and thank my sponsor PCB Way. And yes, PCB stands for printed circuit boards. They are very friendly people, and if you head over to pcbway.com, they can take care of all your hobbyist needs. Besides PCB manufacturing at the very reasonable prices, they also do CNC machining, sheet metal fabrication, 3D printing, injection molding, and they also have advanced high-quality PCB capabilities for your advanced needs. Right now they are hosting their 6th project design contest, and if you want to participate there, you have to be quick because it ends pretty soon. Besides that, they are soon going to start their big Christmas sale. So please head over to pcbway.com and check out their services. So what you see here is the controller cards for these types of machines. Obviously it has a lot of mechanical switches, and some of them had LEDs and sound capabilities, and they featured a lot of security features, like to be able to prevent some attempts at cheating the machine, like putting a coin in a little string and trying to pull it back to win several times, stuff like that. And anti-shaking system, not really sure what it is called in English, but thing is, I got this from a guy here locally that I know a little bit, and he is interested in these machines and has a few in his collections. And by the way, to get a original coin machine or Kronespill nowadays, you can find them sometimes for sale, but it costs like 15 to 20,000 NOK, 1,500 to 2,000 euros, and yeah, there isn't a lot of information about these. I don't know anything about this, and yeah, it's impossible to find technical documentation and schematics and things like that. So I'm quite on my own here, and the thing with this is that one of these is actually working, so I have one to compare with. This is not working. There's even another board that is partly working, and also got some LED displays and sensors with it, so you can actually try it out and see how it works if I manage to set it up. Obviously it needs a power supply, and yeah, I got that too. So let's take a look at the rest of the stuff and see what we have. This is a board that is supposed to be working, and it has a power supply, and here's some big LED 8 segment displays, or in fact it's 7, and yeah, a little bit worn out on the paint, but should be working. Here's one single LED display, and here are some of the tiny micro switches that the coin hits, and yeah, it switches. Yeah, here you can see it. I guess the coin hits this when it falls down some slide or something, and then it registers and you get the prize. I usually don't do work for others, repair work, because I think it's a bit risky. I don't want to do damage to other people's machines or equipment if I'm unlucky. However, in this case, I thought it was kind of interesting, so I'll take a look at least and see if I can figure out anything. I see some of the chips here are not regular LS TTL logic chips, but some other kinds, so I obviously need to take a look at what kind of chips it is, and see if we can figure out something, at least by comparing to this working board. I mean, I have this one, which is the same, but this one, it says that the fuse blows when you power it up, so that is perhaps a short or some electrical problem. However, this one is partly working, and however, it does not count correctly, and it's not quick enough, obviously. I think something like that. There's a note here in Norwegian. Obviously, without the schematics, it's hard to figure out how this thing is wired and how to follow traces and stuff like that. It has a few old electrolyte caps and old power supply with some big old cap, and a large transformer. It doesn't have any connector wire, so you need to provide that with some kind of lead. I think I'll start by trying to power this up, since it says okay, and see if we can make something out of this. Yeah, in the box there's actually two power supplies. They look almost the same, not completely, and a mains cord here, and yeah, with a live wire. So this is not a good idea to attempt if you don't know anything about mains power and the risks about that. So see that the boards are running on 12 and 24 volts, so that's a little bit different than what I'm used to with 5 volts, but that's probably why it has some other types of chips. If we take a closer look at the power supply, it seems to be of a very simple kind. You have this big ass transformer here. You have mains or 220 volts AC in there, and it has 24 volts and 12 volts out and ground. And yeah, seems to be just a couple of capacitors and a bridge rectifier and a fuse and maybe a regulator. Seems to have some additional options here, like a motor speed control or something. That one is actually populated with contact on the other one. There. So maybe it's made for different types of machines that have different features. And I think this one is a fuse as well. Yeah, that's a fuse on the input and fuse on the output, I guess. I'm not an expert on power supplies, at least I can tell you that, but do know the basics at least. So to power this up, we just need some mains into this, and yeah, I guess we just do like that. Turn it a couple of times around and see how it goes. No, I'm just kidding, I'm not gonna do that. Are you crazy? So I need to find some proper way to connect this. Maybe there's something else in the box that is used for hooking it up. I'll check. I used to have a set of these connectors. Not really sure what they're officially called in English. I thought this would fit, but it's too big, so I don't have that size. Well, I guess it's time to head out to the hardware shop and find the proper connectors and crimp them on the wires properly. I'm not gonna risk any shocks or anything here. The wireless microphone ran out of battery anyway, so I need to charge it for an hour, so I have time. I didn't find the correct size on the hardware shop. This I think is 4.8 millimeter cable shoes, I think we call it here in Norway. I'm also going to use my own cable, so I think I just use a bigger size and cut off these ones. These kind of connectors are mainly for cars and boats, I think. 12 volts. So now we can connect. This is still not an optimal connection because these are probably not meant for 230 volts, and yeah, they can short out, so I need to protect them with some tape. Yeah, that will do. Of course, this is highly unsafe, probably not legal, and since this is not grounded, there is a risk of shock, obviously, but I'll obviously be careful. Okay, I have hooked it up. I'm turning on the power now. Let's see what happens. Yeah, not much. Okay, I'm gonna measure the voltage out of this and see if we have the correct voltage. No, there's nothing here. Well, it didn't work because this white cable didn't conduct any electricity. I even measured on the bare wires and nothing. So I had to redo everything, and I got this black one. It's a brand new one, and I measured on it and it is working. Okay, let's test again, and I'm always a little bit nervous when I'm dealing with mains voltage, which you should, because it is dangerous, and you should always double check every connection and everything and nothing shorted, and make sure you don't touch anything. Never trust anybody. By the way, this anti-static mat on my desk, it's currently not grounded. Okay, so I'm turning on now. All right, yeah, so 2 LEDs turned on, this little lamp turned on, and no noise from the transformer. So let's check some voltages then. Obviously you can check if the mains is coming in correct, and it should. Yeah, 235.6 volts, 27 volts and 12 volts. Okay, so this one is working fine then. A little bit over 24, but I don't think that is any problem. So let me just hook it up then. It's this connector here. It's labeled 12 and 24 volts. So I guess it is the correct. There's a couple of more connectors here. I'm not sure what those are for. No markings. Obviously this is not a full system, there's a lot more needed for the machine, and you see it has this connector here and one there. Obviously there are more switches and actuators, motors, perhaps sensors, I don't know. Okay, so I think there's just one thing to do, and that's to power it on and see what happens. Go. All right. Yeah, there's some numbers and some counting. There's a couple of LEDs there. This one shows 0. So, by the way, the numbers are upside down. The first of these machines were purely mechanical. They didn't have any displays or anything. Okay, so it seems it just counts up. That's all it does. I have no idea how to activate this, but yeah, if I try one of the switches, something happens. Yeah, see here? Oops. You can't be too quick. I don't know the logic in this. Apparently there's no CPU in this, but there's quite a lot of logic chips. Yeah, and now under load the voltage is exactly 24 volts. I guess all of these are transistors. They have a heatsink, but none of them is warm yet. They might not be in use right now. That might be for driving some heavier stuff that is not here. There's even socketed chips. Okay, that's enough with testing the working board. Now I'm gonna hook up the non-working board and we'll see what happens then. Because that's the task at hand. It's to see if we can figure out what's wrong with the non-working boards. This is the partially working board, and yeah, it has a note. I can't really understand what the first line says, but it says wrong number and very quick, very fast. Okay, turning it on. Yeah, so here we can see it all displays just zeros. I'm not sure if it's that visible on the video, but it's all zeros in all displays. Then we have this third board, and it says here that the fuse blows, so not gonna power that on. Obviously this can be used as a part if needed, but I'm gonna just take a quick look at it first, see if there's any shorts or anything. I'm not gonna show you the whole process here of diagnosing these boards. I have to do a lot of lookups on chips and stuff like that, and yeah, I'll be back if something interesting occurs. There is no fuse on the board, but if the fuse blows, it's probably on the power supply, and then it means one of the two power lines on the board are shorted or very low resistance. I measured on the working one. It's on the 24 volt rail, it's open line, mega ohms, and on the 12 volt line there's 1 kilo ohm. So we can check here and see what we have on this. If the 24 volt line is open, it's probably used for something else. Yeah, and that's almost open, 9 mega ohms. And the 12 volts, oh, that's quite low, 176 ohms compared to 1K. So that's probably why the fuse blows. By the way, most of the chips are standard CMOS logic chips. Yeah, and here's one example of a datasheet for a set of those, and most are branded MC, and that's Motorola. So there's a bunch of and, or, and, nor, and NAND and stuff like that. Yeah, which is the same as the regular old TTL logic chips. There's a lot of differences. For example, voltages are different, voltage levels, and power consumptions. CMOS chips generally use a lot less power, and they can be more densely packed, and also they are a bit slower, at least the old style. It is for the most part Motorola chips, but there are some TC marked chips from Toshiba. Checked one of those, it was a counter chip. So I can't really see anything wrong here, nothing has been burnt or anything. Everything looks alright, no corrosion. I wonder what this is. Is it some kind of tamper detecting mechanism? It vibrates if the machines are shaken or shocked. So if there is a short or a near short on the 12 volt rail, it is difficult to know where, because it can be anything, and yeah, it can be one of the chips, it can be these transistors, could of course be a bad resistor, and it's difficult to measure that in circuit. So I think I'm just gonna leave this for now and see if I can figure out a little bit more on the other board. So I'm just checking a little bit more about the different components. All the transistors are tip 110, and yeah, it says here it's a transistor designed for general purpose amplifier and low speed switching. So I'm gonna start checking a little bit voltages around the partly working board, and instead of using that old power supply, I just power it with 12 volts from my bench supply. I set it to 12 volts and maximum 1 amps, and only connecting the 12 volt rail. I think the 24 volts is not used for the board. So let's turn it on. Yeah, and it draws actually right below 1 amp, and it actually powered on. All the digits are 0. And now I can check some voltages on the various chips and stuff like that. Also use the oscilloscope. Yeah, and as we can see, all these chips runs on 12 volts and not the regular 5 volts as we are more used to on this channel. Well, the strangest thing happened. I was measuring voltages. I was gonna measure the voltage on all the chips, and I was measuring this one, and I accidentally think I shorted 2 pins on that side, and the board starts counting. Let's see if it continues with that. Just turning it off and on. Yeah. What the heck? Did I jumpstart? Was there something with this chip? Not sure. I'm gonna power it off for a while and see if it still continues. I mean, I'm not sure if I shorted anything. At least I touched it with the probes, and I heard a little click, and then it sprang to life. So it might be just bad contact in the socket. I'm gonna check this chip, figure out what it is first. Then clean up the socket, which is always a good idea. A little bit of contact cleaner, maybe the rest of the socketed chips as well. Yeah, and I can see one of the pins is quite bent. I did not do that. I'm gonna straighten it a little bit. This is a so-called Schmidt trigger. I just took out the rest of the socketed chips. I'm gonna clean up the sockets. And the chips I just clean off gently the legs with the fiberglass pen. Then I'm just gonna clean off with some contact cleaner and on a cotton swab afterwards. Yes, and as you can see, there's a good deal of oxidation already coming from the second chip. By the way, many of these chips are marked 1981 and 82. Okay, so I cleaned all the chips and the board actually stopped counting again. Since it started when I touched this chip here, I actually swapped it now with one from the other board, and yeah, still doesn't do its thing. I checked the voltage in on all the chips are good, around 12 volts, 11.7 something. Okay, so the next thing I'm gonna do now is just to one by one swap out all the chips that are socketed with one from one of the other boards and see if that does anything. Yeah, I'll do that before I start pulling out the oscilloscope. I'll take the chips from the known working board. Luckily enough, it's the same chips that are socketed on all the 3 boards. I wonder why. Maybe these are chips that are more known to be failing. So I swapped back and forth all the chips I could, and that did not help. Also testing some of the chips in the Retro Chip Tester Pro. It can test the 4000 series CMOS logic. So just select that, and this is a 4022 3-bit binary counter. Alright, let's test. Yeah, that passed. So that's my next step. Again, just to test all the chips I can. Now, I actually think I found one bad chip. This is MC14584, the so-called Schmidt trigger, and that's the chip I mentioned before. I touched and it started working, and I have set it to 4069, which is the equivalent chip, and it actually fails. And if I test with the other chip, the same chip from the other board, that one passed. Do we have a bad chip? Yeah, can't get this to pass. However, the board still didn't work with the chip, so that might be something else. Well, it does work. Maybe I was a bit too quick before, and it takes a while before it starts, but you see now it starts counting. Cool. So just to see that it isn't just a fluke moment, putting back the original chip. Yeah, now it just hangs there, does nothing. Okay, so I just replaced the chip, and this is the one from the faulty board that breaks the fuse. So, testing again. Yes. And the switches, yeah, they work too. They did not work when I had the faulty chip in. Okay, just mark this as bad then. I'm gonna let this run for a while and see if it is stable. Okay, so the board has been running for a couple of hours, and everything works still, and today is the next day and it's still working, so it definitely was that chip. So now I have actually understood more how this works. On the real game, under each of these LED displays, there's a slot where you're supposed to shoot a coin and hit one of the slots, and the prize you win is the actual number whenever the coin hits the slot, and the prize you win is this number, and you get this number of coins down into the compartment below the game. Yeah, let's actually take a look at the video how this actually works in a working machine. Yeah, here you see the same kind of machine, and you see how it has the displays over the coin slots. I got some more inside information about these types of games, and in fact it is a Norwegian invention, and the earliest types of these machines were actually made in the 1930s. This particular machine was made by Lars Berg in Trondheim in Norway, and it's called the Lars Berg Silver Line. The top price on these were 9 kroners, and Lars Berg had some patents, and he actually was in some lawsuits or whatever with other companies copying these machines, so yeah. But later, of course, they were outdated and replaced by other machines where you can win bigger prizes and banknotes instead of coins. Now Knut, the owner of this equipment, told me that I needed to test that some solenoids are activated. That's gonna be activated the same number of times as your price, which should then be activated 5 times in a row in this case. And he said he thought some of the LEDs should blink 5 times, or the number of times it was activated. But I can't see anything blinking here, so I need to figure out another way to measure that. So I now hooked up the original power supply just to see if it needs 24 volts for that, but no difference. So it could be that some of these pins or these over here then are activated. I need to check a little bit around and see if I can figure it out. To check out that, I'm going to use the oscilloscope. I have this picoscope that connects to a regular Windows PC. This is still the working board, and I have been trying now to figure out what is triggering when you have a win, when one of these switches are activated. And I have used the oscilloscope on this connector because this is the one that connects to the solenoids on the actual coin device, and I can't see any changes in any signals. However, I figured after a while that there is actually no ground pin here, but there still is 24 volts on this one. So here is the scope screen, and yeah, as we can see, there's a little bit wavy 24, 23, 22 volts signal there, and a couple of more pins, but all the rest are not doing anything if I trigger a win. So I was wondering if this board actually needs to be connected to the actual mechanism in order to trigger that. Here I'm measuring some of the chips, and they are on 12 volts level, and as you can see, there's actually some kind of clock signal on some of those, and the frequency here is 6 to 7 kilohertz, and on this pin it's 16 kilohertz. Anyway, Knut, the owner, was here, and he came with this. This is the coin mechanism, and when you hit a coin and it flies over here and hit one of the slots, and the coins fall down one by one. But the interesting piece is in the back. So here's all the solenoids, and if you win like say 3 kroners, this will kick in 3 times. And out. Yeah, and there I won. Coins behind there. So I'm actually gonna hook this up now and test it. However, that will of course be some kind of arrangement here in my lab. I'm not really sure how to pull this off. And it needs to balance not to fall over. So I think I need to clear the desk a little bit and see if I can make this work. Not entirely sure how the connectors goes into the contacts. However, looking at the other two, they appear to have been in the same direction. They have this ridge here that goes into these clips, and yeah, I guess it is correct then, but they go in both ways. Anyway, I think I have to put it down to my floor because this is too unstable and too little room. Now it's hooked up, and yeah, it's down on the floor, but there it can stay against my desk leg there. Everything is connected. I can turn on the power, and we can actually see this is with the working PCB, by the way. So this should work first, and then we can test with the repaired one. Okay, I powered it on, and yeah, it still counts, and nothing else happened. So let me try and trigger a price. Yes, I won. Yeah, here's the display of the price. Won. one again. Try one of the other. Depending where you hit, if you hit in the middle, you can potentially get a higher price than out here, for example. It stops at 4, 2, 4. Okay, how cool is that? So you see it delivers coins from the different slots, and when one slot is starting to empty, then it starts using the other slots. And of course, when players are playing, these will fill up, and when everything is full and you risk an overflow, then the coin will run down here and collect down into the machine, and that's how they make money. By the way, these are the old Norwegian kroners. These are not in use anymore. Today we are using smaller coins. Alright, so let's hook up the other board then and test. So I think I never had to sit on my floor before when testing old stuff. This is the one I fixed. Just gonna disconnect power and hook it up. Okay, that was a bunch of hassle, but now it's hooked up. Let's check. Yeah, one, 2. I only win 1. So that was a price of 5 and only 2 came out. So maybe this isn't working as good as it should. I think I accidentally pulled one of the wires because I see now one wire is loose on the contact that controls the solenoids. Maybe it was loose from before, I didn't notice, but I tried to put it back, but still don't want to give out the correct amount of coins. So I'm not really sure what's going on. Yeah, here you see one wire is loose. I think it goes there by the looks of it. So I need to try and fix it down to the contact properly, see if that helps. These are some old kind of contacts I have never seen before, I think. What a mess. I'm lying on my knees on the floor testing a little bit more, and yeah, I fixed a little wire and tried with the other working board and everything worked. However, I did test all those chips now. If we take a look at the working board, I mean the chips on this row, and they were all fine, because I think these chips controls these transistors, and there's 12 transistors, 1 for each solenoid. I tried to take out some of the chips, and then none of the solenoids were triggered, so clearly they are controlling these transistors. So I'm thinking, since all the chips are okay, maybe one or more or the transistors are bad, so I'm gonna try and test them a little bit now. Of course, to properly test the transistor, you need to use a transistor tester, but first off I'm gonna just start measuring, and this is the transistor base collector emitter, and see if there's any shorts, or yeah, try to figure out if the voltage drops are correctly. These are a little bit more advanced than just a regular transistor. Anyway, I can compare with a working board to see how it's supposed to be. To properly test the transistor, I need to desolder it, but I'm first gonna try and pinpoint which transistor I'm gonna need to desolder. So here's what I found, and yeah, it can be hard to measure in circuit, but at least for a couple I measured between base and collector. It should be open, and between collector and emitter it has a voltage drop of 0.55 volts, and over base and emitter it was 2.4 volts and 9 kilo ohms, and over collector and emitter it was a resistance of 1.3 mega ohms. Here's that faulty board. Let me just start measuring. Should be open line. Yes, in fact this board and these transistors, they look much better than the other one. And then between those 0.54, 2.4, yeah, that looks alright. 2.4, 0.55. Okay, so I'll just go through this and see if I find anything. The only one I found that deviates a little bit is this last one here. You see over here there's a voltage drop of 0.8. There's around 8k resistance between base and emitter on every one except the last one. It's down to 780 ohms, so definitely this is different than the others, unless there is something in the circuit that makes it stand out. But I mean, there's 12 solenoids and 12 transistors, and they are all the same kind, tip 110. And the voltage drop was 2.4 on everyone, but on the last one it drops only 1 volt. So okay, my next step now is to solder out this one and replace it with the one from the totally faulty board. A little fresh leaded solder first makes it easier. Hot, hot. Well, in fact, this transistor has been bent so many times that it has broken 2 of its pins. So yeah, the third one is almost off. This one has been bent a little bit too. It's all loose. This one seems a little bit firmer, so I'm gonna take this one instead. This is from the Pajazzo board. Let's test the transistor I took out of the Pajazzo board. Hopefully it is working. This is a simple component tester. It says here it's a BGT NPN transistor, and it gives us some values here. So let's try the suspected non-working, this one. Yeah, it says the same, but it has different readings. And if you remember, I measured just with the multimeter the resistance. Let's check now. This is the suspected one. It has a resistance of 800 ohms, while the one I took out 10k. So yeah, I'm gonna solder in the one I took out and check if that fixes it. In you go. Yeah, that looks good. Okay, ready to test. So do we get the required coins? That was 1. That was 3. Should have been 3, but it wasn't 3. No, still not fixed. It's still not producing the correct number of coins. Well, it seems like it's activating the solenoid the correct number of times. Now this slot is empty. I got 3 and I heard it bang 3 times. 1, 1, 2, 3. Yeah, definitely. But of course it should continue with the non-empty slots. One, two, 3. Definitely 3 bangs. But still not working correctly, because it should obviously eject coins from the other slots if this one is empty. So it probably wasn't a transistor after all. Maybe it was just a little bit off in values, but I think more of that it maybe is some feedback issue from the coin mechanism. It sends feedback through some sensors that a column is almost empty, and then it should continue using coins from another column, so it should distribute the ejection of coins over all the columns. That does not happen. So since it's working with the working board, then I think maybe some of the chips, maybe one or more of the chips that controls that feedback is not working. However, it's impossible without the schematics to figure out what chips are involved in that. I mean, all the socketed chips I have tested, they were working fine. So I think maybe I'll try to trace back and see what chips are involved in that, and maybe if I find one that's bad, I have to desolder it and replace it. So there's a sensor there. It's pushed in when there are two coins, and if there's only one coin, it's not pushed in. And I see that sensor goes to two orange wires, and there's two pairs of orange wires on the contact here. So I can trace from those and see what it gets. So that's pin 6 and 7 and 12 and 13. And yeah, so that should be possible to figure out where they are going to. I traced the two pairs, and 6 and 7 goes between ground and this chip, and 12 and 13 goes between ground and this chip. So that's a little bit strange. These chips tested okay. I could always try and swap them out with the ones from the other board. Let's see if that helps. But then again, it can be a signal that controls these chips, so maybe trace a little bit further in, see if we can find the source. But in fact, they actually brought some spare chips, apparently bought from China, so might want to test those instead. There's the 4022. Yeah, and here's the 4072. I'm gonna quickly test those. You know, China chips, you never know what you're gonna get. Yeah, they both tested okay, so I inserted the new chips. Let me just quickly check if that helps. I tested and still the same, so probably not anything wrong with those chips as I suspected. Then we need to just trace further on. I'm concentrating on this chip, the 4022, and this is definitely connected to one of those coin sensors, and this is in fact an octal counter, and I guess it is controlled by some other chip, either sending signals back or are controlled. It has a clock signal input on this side, and a reset, and a carry signal. But that carry signal is not connected anywhere, it's not in use. So I'm going to check with the oscilloscope if we have a clock, and the reset line is connected to this chip in fact. So this is connected to pin 13, and the other pins are also connected to this connector that goes to the coin device, and all are in some way connected to the connector. So those are the outputs or inputs for the counter. I'm not really sure about that counter, how it works. So now I scoped a little bit on this chip and the signal from this chip as well, and it all is normal, or at least the same as the other board, which I also tested, so I don't think there's anything wrong there. I mean, I heard 3 clicks from the solenoid, but only 2 coins fell out, so what is about that? I mean, the mechanism is simple. The solenoid is pushed in, a coin falls out, it retracts, next coin falls down, it pushes in, retracts, and pushes in. And then you have these sensors that indicates there's only 1 coin left. All this works, we know that, because we tested with the working board. Then it must have something to do with controlling the solenoids, either timing or something like that. There is a LED on the PCB that actually blinks when the solenoid is activated, and it actually blinked the correct number of times. When the price was 3, it blinked 3 times and I heard 3 clicks. I could of course just randomly start to desoldering chips and swapping them out, but I don't want to do that, because then you don't know what actually is going on, and there's a certain risk in desoldering chips. You can damage the board, you can rip out some pads or traces, so it's better to figure out what chip you need to desolder. At least you have a little suspicion on one. What I can do is to start checking all the chips, all the pins and all the signals on all the chips, just to see if something looks off, if there's some perhaps noise or low value or something like that, floating pins. Yeah, I think I'm gonna do that next. I'm back again and I think I got it working. What I did, I checked all the chips on the card with the oscilloscope, just to check that there wasn't something terribly wrong on some chips, some floating lines or some way off voltages, and everything looked alright. Then I was thinking these switches, and there's a couple of potentiometers here. These are for adjusting how far the counters on the outer and inner numbers are gonna count. So this is set to 7 and this is set to 3. So these count only to 3 and these count to 7. However, the potmeters here, there's one there, and they control, in fact, the speed of things. And actually I got a little document here, and it says here T1 adjusted the speed of the numbers and T2 adjusted the speed of the payment, and T2 is here. Then I adjusted this pot a little bit, because as I said, it sounded like the magnets kicked in the correct number of times, however still not the correct number of coins. So you can now actually see the magnets in the solenoids kick in. Let me try and activate it. 1, okay, 2 coins, 3, 1, 2, 3, yeah, 1, 3. You can't see the coins fall out, but I can see it from here on the other side. So then, this is working. However, it seems to be a little bit unstable, because now suddenly the numbers stopped again. They're not counting at all. However, I'm gonna end this video now. Why this stops counting suddenly? Probably some instability in one chip. Maybe it's the one I swapped there in the first place. I'm gonna try swap it out again. Oh, I figured out why it stopped counting and everything was in 0. One of the switches actually lay down to the floor and was activated all the time. As soon as I lifted it, it started counting again.
Yes, so this is my hobby, my project to renovate this old game. It's like a flick a coin game. You put a coin in here, you flick it here, and you're supposed to hit one of those gates here. They have a little switch inside, and the numbers here, as you will see later, they will count from 0 to 9. So if you're lucky, you get 9 kroners, about yeah, less than $1, less than €1. But if you're lucky, you could hit it twice or 3 times. So it's a good game. It's a combination of technique and luck, mostly.
Okay, great. Thank you.
Yeah.
So now he's assembling the car that I repaired. So luckily it's working. Yeah, the car is hooked up now.
Yeah. And it's counting.
Hey.
Close call.
Hey.
Oh, come on. It won't pay out. Nope. No price.
Alright, I'm gonna end the video here, and I hope you found this a little bit interesting. I for sure did. Not regular computer content, but I like to do all kinds of stuff from time to time. So a little bit of Norwegian history there, and nostalgia and mechanics, but it was fun. And now I'm gonna take a look at this board and see if I can figure out what's wrong with this one. So thanks a lot for watching, and thanks for all the subscribes and likes. Hope you will hit that like button, and special thanks to my Patreons. See you, bye bye.